In the previous video, I described a set as a logical boundary. A set separates a universe into two possibilities. The selected element is either part of the set or it's not part of the set. And according to the membership condition, we assign either a 1 or 0 for each of the elements in the universe, U. And so what happens when we introduce two sets? So let's just suppose that we have these two sets, A and B, and they have different predicates associated, different logical boundaries placed within the set. And so what happens if you want to combine these logical boundaries? P of x and Q of x. Well, in order to operate these, we need different tools. And our first tool, the first tool that we might need to combine these predicates is called an intersection. Symbolically, it's like an upside down U pretty much. And in everyday language, it will be translated to the word and, or they're going to talk about in the next video. But an intersection, this is a symbol, and this is the English word for it, right? So the intersection of these two sets can basically contain the objects that belong to both of these sets. So the intersection, that the common area or the gray area, that's where we're interested in. So, and since membership A means P of x, and the membership B means Q of x, we get this statement here, where there's an arbitrary element, which is placed in the, the gray area between these two sets. That means that the predicates has to be both placed. So x has both these predicates at the same time, present. Okay. So again, intersection means and. And so we've got an example here where I've given specific predicates for both of these sets. If I want to see find the intersection of these, well, I would need my arbitrary element x to be an even value as well as a positive value, right? And structurally speaking, I don't know if you've noticed something interesting about an intersection. It basically creates a narrower region. Okay, so let's maybe do this nice visual here. Please, better. Here you go. So this is A, the region of A, and this symbolizes all of the values that we have. Okay, all of the integers. Your circle is going to be B, where it states all the positive values, the positive integers. And X is just like this little middle region where both of those predicates are present. So obviously there is this idea, structurally speaking, there's this idea of a narrower region. That intersection creates a narrower region. Because with our next video, we're going to see a thing called union, where it obviously combines predicates, but in a different way. So, yeah, you can check that video out if you're interested in the union.